Okay, now for the resultant of force systems. Okay. Now for the introduction, the effect of system of forces on a body is usually expressed in terms of resultant. The value of this resultant determines the motion of the body. If the resultant is zero, the body will be in equilibrium. The body will be in equilibrium and will not change in its original state of motion. Now, we have the y-axis, force and component. We have the y-axis and the x-axis. Always remember for the first quadrant, you have positive, positive. For the direction of your x, you have positive. For y, you have positive for the first quadrant. While for the second quadrant, we have negative for x, positive for y. And for the third quadrant, we have negative for x, negative for y. And for the fourth quadrant, we have positive for x and negative for y. Going to the right, positive. Going to the left, negative. Y, positive upward, negative downward. Okay. Note, going to the right, positive. Going to the left, negative. Upward direction is positive. Downward direction is negative. Now, example number 1, explanation for getting the polar and Cartesian coordinate. When you say polar coordinate, that is your F and theta. That is for the polar coordinate. While the Cartesian coordinate, you have your F and theta. While for the Cartesian coordinate, you have your F, X, and Fy. Okay. Okay, now for Fx, using this one, you have Fx that is equal to F cosine theta. Why F cosine theta? Using this triangle, this one is a right triangle, you have your Fx and Fy. Okay. Therefore, we have cosine theta. Cosine theta. Remember that your cosine theta is equal to adjacent. Fx is the adjacent side over the hypotenuse, which is F. That is why we have Fx is equal to F cosine theta. Then for Fy, okay, Fy now, okay, remember the formula for the trigonometric function. We have sine theta is equal to opposite is your Fy over the hypotenuse. That is why we have Fy is equal to F sine theta, cross multiply. Then, using the formula for Pythagorean formula, in finding for your F, you have F squared is equal to Fx squared plus Fy squared. Okay. Remember the Pythagorean theorem, the square of the hypotenuse is equal to the sum of the square of the other two sides. Kaya we have F is equal to square root of Fx squared plus Fy squared. Okay. Now for the tangent, okay, for the tangent theta, finding for your theta, tangent theta is equal to tangent theta is opposite over the adjacent side. The opposite side is your Fy, the adjacent side is your Fx. Okay, therefore, using this one, your theta is equal to arc tangent Fy over Fx. Note, F and theta are polar coordinates. Fx and Fy are the Cartesian coordinates. Okay, example. A and 40 degrees is under the polar coordinates. Your vector A and your 40 degrees is under the polar coordinates. That is the hypotenuse and the angle theta are given. Therefore, it has a Cartesian coordinate. Therefore, we have your X and Y. Since your vector A is lying on the first quadrant, you have your Fx lying on this one. You have your Fx and your Fy. Okay, using this formula, okay, the requirement now is, okay, what if the requirement is your fx or fy? Instead of f, let us, since vector A, let us use this as your ax and ay. Now, the requirement now is to find for the Cartesian coordinate, your x and y. Okay. Cosine 40 degrees is equal to adjacent, which is ax over ax is equal to a cosine 40 degrees. Since your vector A is equivalent to 30 newtons cosine 40 degrees. Okay, your AX now is equal to 22.98 newtons. While for AY, okay, let us use the sine 40 degrees, which is equal to AY over AY. We have the opposite over the hypotenuse. Therefore, we have AY is equal to A sine 40 degrees. Substitute the value of your A, which is 30 newtons, times sine 40 degrees. Okay, therefore, your AY is equal to 19.28 newtons. Okay, next. Now, second example. Okay, a force of 100 pounds is directed as shown in the figure. Determine the x and y component of the force. Remember again, the given is under the polar coordinates. You have your 100 pounds and 35 degrees. But the given figure is lying on the second quadrant. The requirement is to find for your Fy and Fx. Okay, let us try to solve this one. Given F is equal to 100 pounds and the given theta is equal to 35 degrees. The requirement is to find for your Fy and Fx. Okay, for Fx, you have Fx. Okay, we have cosine. Cosine 35 degrees is equal to Fx over F. That is adjacent over the hypotenuse, where Fx is equal to F cosine 35 degrees. Substitute where F is 100 pounds, multiply by cosine 35 degrees. Okay, we have Fx is equal to 81.92 pounds. Okay, remember that your Fx is lying on the second quadrant. Therefore, the direction would be negative. Why? Because according to the lecture, if the forces is lying on the second quadrant, your x is lying, the sign of your x is negative, and for your y, you have positive. Okay. Now, for Fy, we have your Fy. Okay. We have sine 35 degrees, which is equal to opposite over the hypotenuse. Therefore, your Fy is equal to F sine 35 degrees. Where F now is equal to 100 pounds sine 35 degrees. Now, for your Fy, we have 57.36 pounds. Next example. Okay, determine the components of the 200 pounds force directed down to the right at a slope of 2 to 3 as shown in figure. Okay, there's no given angle, instead the slope is given. This one is 3 and 4. If this one is your angle, theta, Okay. What formula are we going to use to find for your angle theta? Okay. We have what? Tangent theta is equal to opposite over the adjacent, where theta now is equal to arctan 3 over 4. Theta is equal to what? Okay, therefore your theta is equal to 36.87 degrees. If you're not familiar in using the slope in finding for your fx and fy, you can use this one, the formula in finding for your angle for the polar coordinates. Therefore, if this one is 36.87 degrees, and remember that your f is lying on the fourth quadrant, the condition would be your x is positive but your y is negative. Okay, let us find for your f. This one would be your fx. And this one would be your fy. Now, for fx, we have fx, which is equal to f cosine theta. For f now is equal to 200 pounds multiplied by cosine 36.87 degrees. Okay, therefore we have 160 pounds. Now for Fy, we have Fy is equal to F sine theta, which is equal to 200 pounds sine 36.87 degrees. Okay, therefore, this one is equal to 120 pounds. Since your Fy is lying your Fy is lying on the fourth quadrant, therefore your y is negative. Okay, now, okay, this one would be the solution for the problem number 2. Okay, first, get the value of the hypotenuse of the slope. Okay, we have your r, 3 and 4. Using the Pythagorean, you have r is equal to square root of 3 squared plus 4 squared equal to 5. We're talking about the right triangle here. Okay, then your r now would be equal to 5. Okay, therefore, you have your 5 plus 3 and 4, fx and fy, and then your vector f, which is 200 pounds. Now, find for the value of fx and fy. We have fx, which is equal to f, that is 4 over 5. Kasi we have 4 over 5, that is fx. Eto, this one is your fx. Therefore, that is under the sine law, 4 over 5. 200, therefore that is 160 pounds. For Fy, we have negative F 3 over 5 equal to negative 203 over 5, which is equal to negative 120 pounds. What have you noticed? You have arrived at the same answer. Okay, another example. Now, determine the x and y component of each of the forces shown in figure. Okay, each component. Therefore, first, we have your vector F, which is 300 pounds and 30 degrees. Okay, for this one, you have your, since your force F is lying on the first quadrant, you have your Fx here, and then you have your Fy. Okay, now for Fx, we have F cosine 30 degrees. Then substitute the values. You have 300 cosine 30 degrees is equal to 259.81 pounds. Now, for Fy, we have Fy is equal to F sine 30 degrees. Therefore, that is 150 pounds. Now, for point vector B, we have 300 pounds, 12 and 5. Get your hypotenuse. Okay. Get the value of the hypotenuse for the given slope for vector P. That is what? R, which is equal to square root of 12 squared plus 5 squared is equal to 13. You have your 13. Okay, therefore, we have Px and Py. Okay, now for Px, since your vector B is lying on the second quadrant, your Px now becomes negative. Therefore, we have Px is equal to negative P 5 over 13 equal to negative 300 5 over 13, which is equal to negative 115.38 pounds. Okay, for Py, we have equal to P 12 over 13, which is equal to 300 12 over 13, that is equal to 276.92 pounds. Now, for your vector T, we have 400 pounds and 50 degrees. Remember that your vector T is lying on the third quadrant. Therefore, the sign of your X is negative and the sign of your Y here is negative for vector T. Okay. We have Tx is equal to negative T cosine 50 degrees, which is equal to negative 400 cosine 50 degrees. Therefore, that is equal to negative 257.11 pounds. While for Ty, we have negative T sine 50 degrees, negative 400 equal to, negative 400 sine 50 degrees is equal to negative 306.41 pounds. Okay, therefore, you have your Tx here and Ty. Next. Okay, next problem. Okay, the triangular block shown in figure is subjected to the load P, which is equal to 1,600 pounds, and force F, which is equal to 600 pounds. If AB, this one AB, is 8 inches, and BC is 6 inches, resolve each load into components normal and tangent to AC. Now, let us proceed for the solution. Okay, this one is the solution for problem number 4. The requirement is the tangent and normal for this given figure. First, you have to find for your angle theta. The angle theta here is equal to tangent theta is equal to 8 over 6, where theta is equal to arctan 8 over 6, which is 53.13 degrees. If this one is your angle theta, this one is also your angle theta. Kaya we have 53.13 degrees. Now, for tangent P, we have this one, that the direction would be this one. You have your PT. This one would be your PT. Force P, tangential for force P. And then the normal is this one. This one would be your PN, the normal. Now, for PT, that is PT is equal to P cosine theta, which is equal to 1,600 pounds cosine 53.13 degrees, where PT now is 960 pounds. The direction is this one going upward. While for the normal P, we have PN is equal to P sine theta, which is equal to 160 pounds sine 53.13 degrees, where PN is equal to 1,280 pounds. If you're going to rotate this one would be your figure. You have your PT here, and then your P, this one is your angle theta, and this one is your PN. That is the reason why we have PT. We have PT is equal to P cosine theta, and for the normal, we have PN is equal to P sine theta. Okay. Now for your F, Now for the solution for illustrative problem number 4, this one is your FT and FN. Okay. Free body diagram. You have your FT here. You have your F. And then you have your FN. If this one is your angle theta, therefore this one is your alpha, where alpha is equal to 90 degrees minus theta. 90 minus 53.13 is equal to 36.87. Therefore, this one is your alpha. And then for FT, that is equal to F cosine alpha, which is equal to 600 pound cosine alpha. FT is equal to 600 pound cosine 36.87 degrees, which is equal to 480 pounds. Okay, for Fn, we have F sine alpha, 600 pounds, times sine 36.87 degrees. Fn is equal to 360 pounds. 360 pounds. Okay, the direction is this one.